Get very steep slope on the west and gentle slope on the east. Definitely the rate of erosion on this side will be very high and the valley slopes are retreating and valleys remain there as it is. The slope is removed here and the source of valley has been cut. You will get very wide source, which is not actually expected. So these are some evidences earlier scholars have given, and there, as I told you, there are two theories. One is retreat of slope, one is faulting. Okay, so we'll see some of such evidences, and one more interesting thing. What do you see here? Valley, okay, straight valley. Across one valley, there are two valleys. One is east-west and other one is north-south. We are facing north now. Okay, why this is so? This is because of the lineament or dike, you can say, and we are exactly standing on the dike. Can you trace this dike on your backside? Yes, and even on the road. Okay. Particularly younger people, they can identify this.
But,
basalt.
In dike, the rock type is different, or
that's what I am asking. Can you identify the dike?
Just we can identify some.
Yes, I'll tell you later. Just look at this side. One more interesting part. You can see very straight line, right, across the valley, very straight line. And you'll get very dense vegetation in the valley part, the opposite side. That is an indicator of availability of moisture and soft rock. In remote sensing, this is one indicator. How will you identify dikes and lineaments? So along these weaker zones, along the softer material, you will get good growth of vegetation. And that straight vegetation line you will identify in remote sensing. I mean satellite images and aerial photos. This is one indicator. Throughout the year, this valley remains green, this part. You can see the north-south valley, okay? We are facing north. So this remains green throughout the year. And the vegetation over here is semi-evergreen vegetation. So throughout the year on the crest, you will get semi-evergreen vegetation. And vegetation is one of the important indicators of change in material and moisture in this area or everywhere. So we can identify change in vegetation also and change in moisture level, and accordingly you can also count the stratas, how many such stratas are there. If you look at the vegetation here, you will get once clear scarp, slope surface, then you will get line of vegetation. Again you will get scarp, okay. So this is how you can identify number of layers. See this one, the top part of this ridge is having vegetation. Then there is empty area or non-vegetated area, that is free scarp. Again you will get a vegetation line, again you will get the scarp. Now here on the back side, at the top there is a gap, okay, there is a gap, that is dike, and if you trace down that dike up to bottom, you will get the difference in material. Both the material is same, basalt, but the joints and cracks are different in dike. So we'll go to that side and I'll tell you how to identify that. Come. Basically I'm not geologist, but we have heard that.
Which direction maybe?
Near Goa, entire part is basalt. So that is very interesting. And what you can see here, why we stop here normally, you can see different layers, different stratas of basalt. Now at some places you can literally count how many such stratas are there. And how will you identify? There is bare surface, you can see in front of us, bare scarp, and then you'll get one vegetation line in between, okay. Then again it is followed by bare scarp. Like what you'll see on the back side, the entire cliff is bare with very few grasses, okay. Then you'll get a line of vegetation. So you'll get alternate bare part of the scarp, then vegetation, again you'll get the bare scarp. So you can count how many times the eruption took place, okay. Near Bhusawal station, you might be knowing, those who travel towards the east and towards the north. Near Bhusawal the place Bhusawal. Scientists, they have calculated and counted the depth of the basalt. So that is about 1000 meters. And if you check Bombay High, all of you know Bombay High, right? Bombay High is oil well in Arabian Sea. They also found the same stratification what we see over the surface. So of course it is the faulted part. And now what is happening when we'll move towards the west, I'll show you the place where we can see very flat surface, which is of course not related to such kind of domal shape. Like there are three domal shapes. One is Trambakeshwar, second one is Kalsubai, and third one is Mahabaleshwar. So if you look at the entire topography and the profile of these areas, you'll find that on the west side it is very high and it is gently sloping towards the east. But from this highest part towards the west, it is very steep. What we see today here, and of course I'll show you one more area, very steep slopes. Now this is very steep. Why this is so steep? It is because of faulting. This is one theory. It is because of faulting of this particular crest, from the crest. So you'll get same stratification at the Bombay High, which is below the sea surface, sea level, and you'll get the same stratification at the higher elevation. So that again proves that there was faulting. But now there is one more concept came, that is how it is possible on such large scale. Then some people say it is retreat of the slopes. There is one theory that it is retreat of the slopes. And there are some evidences how we can prove that. So the rivers which are rising on the Western Ghat area near the crest, they are having beheaded valleys. The valleys have gone. Their source region have gone. The valleys are quite wide, but the streams are too narrow, too small. So these are the misfit channels. Like Lonavala, some people went last time.
Yeah.
Near Lonavala, we have Indrayani river. So the source of Indrayani is quite wide, but the stream is so small, which cannot erode entire valley. So that is misfit valley kind of structure you'll get. There are many such examples. River capture, misfit valley. These are the evidences. Professor Kale has also written in his book and in many other papers that this misfit valley is an indicator. You won't find on this side. It is relatively narrow one, and it is widening because of the erosion on the opposite side. This kind of material you get in amygdaloidal basin.
Yeah.
Okay, spit, the white spots are there, and the other one is massive one.
Another.
Lowest part. So we were crossing the lowest part, but all other peaks are very high. You can check all these peaks. And this is the northern side. Desert road is northern side.
Probably dolerite, exactly জানি না হতে পারে কারণ মানে বেসল্টের থেকে ওটা একটু লেস রেজিস্ট্যান্ট বলে ওইটাকে ধরে ওরা এই সিঁড়িটাকে বানিয়েছে যাতে একদম নিচের অবধি যাওয়া যায়। এখান দিয়ে কষ্ট করে ওঠা হয়, ওই জায়গাটা নষ্ট করে দিয়েছে পুরো প্ল্যাটফর্মটাকে।
সিঁড়িটাকে বানিয়েছে সেম রক দিয়ে।
ওই যে তোমার বিচ দিয়ে যে আসতাম না, ওইখানে তোমার ওই মন্দির
দিকে বিচ তো যাওয়া যায় না প্ল্যাটফর্ম থেকে। আমি যখন এসেছিলাম
মন্দির থেকে ওদিক দিয়ে নামা যায়, কিন্তু ওই জায়গাটা পুরো ওই বাঁধিয়ে দিয়েছে টাইল ফাইল লাগিয়ে।
And I'll ask you to observe one important indicator. One important indicator that you have to observe. Okay, just on the way only. Just follow me.
indicator for
Indicator. Yeah, just check. You do the observation and then I'll tell you. You follow me, okay? Be careful. Be careful. There are four participants. And one more Bala, except Bala. Only one is there. Yeah. But you got 8 papers, no? 8 or 9?
3 from Periyar University.
Okay. Periyar University. They are there? They were there?
Yeah, in the
Come. You are the only person who told me that signature. Where's that you have taken only photograph? Notice, what is that?
Taponi.
Yes, honeycomb structure. Okay.
Taponi.
The taponi, that it is extended.
Extended then that part will be
Yes. Basically, taponi is dominated in arid conditions.
Honeycomb.
You'll get better honeycomb structures than this, but you just check honeycombs are here. And sorry. Okay, sir. Now you know how honeycombs are formed. Do you know how honeycombs are formed? How?
Sir, by the wave action, the soft particles of that rock.
Is it direct wave action or
it's a chemical.
Yeah, chemical.
Yes. It is the spraying of water first.
Then
Water is spraying. Okay. And the water gets evaporated. What remains behind? Salt. Salt plus the chemical weathering takes place, and the spots, the pitting increases. Okay. Now, do you see direct action of water over here? No. Sea waves are far away from this. This is one, and there was one more, one place. At that place, we got honeycomb also, right? This is slightly higher, maybe 2 meters higher than this. This is almost 2 meters higher than present sea level. And this is bay part, so there won't be direct wave breaking. Now, when the wave breaks, then water gets sprayed. Okay, spraying of water takes place, and because of that, the honeycombs are formed. Now, it is one important question: why the honeycombs are lying here? Why the honeycombs are there? That means that simply means the water was reaching up to here, and the waves were getting broken, and it was spraying the water on the surface. And because of that, honeycombs are formed. This is not transported, remember, this is not transported. It is not single board rock. It is complete rock. Okay. Same thing is there about that particular rock. We have seen just now. And you will get such incidences of change in sea level. So earlier sea level would be up to this level. And now it has gone far. Since it is bay part, you can imagine what was the earlier condition. The waves were directly breaking up to the base of this rock.
So sea level is lowering. In this part.
No, in this part.
In this part.
Yeah. It could be because of extension of that speed. Direct approach of the wave is stopped, right? And bay formation is there. Could be different reasons. Since we have not studied that, I cannot claim why it is happening. But this is an indication. Waves are not breaking at all. This is mangrove, so there is no question of breaking waves at this level. Right?
Maybe these were planted, or maybe
No,
natural afterwards.
Yes.
Afterwards.
Right, mangrove, you people know mangroves, right? There is no need to go up to mangroves. If you want, you can go up to that level. And there you might have seen very smooth surfaces like potholes. Have you noticed those areas? Here also you'll get some. Come. Just have a look and we'll go back.